It's nice to be back in Kiev speaking at XP Days. I love coming back to this conference every year. So it's nice to be normal this year. I'm the guy who turned up last year with no teeth and black eyes. And I actually feel like a normal person this year. So it's nice to actually be welcomed back after that. This is a talk called Sustainable System Testing with Chaos. Okay, this is an interesting talk because chaos engineering is a new thing, or we will see that it's actually not a new thing going through. I'm on the internet at Stack72, so if you need to ask some questions after the talk, please get in contact because this is usually a 1-hour talk that I'm trying to compact into 60 minutes. So I'm a platform lead for Samsung Research. I love infrastructure. I'm a DevOps extremist. I love going and speaking at conferences about DevOps, and I'm currently in the middle of building a brand new cloud for Samsung from scratch, from the ground up, and we're actually implementing all of these practices that I'm going to talk about today as we build the system. So, anyone know the term distributed systems? So distributed systems is something that's come about in the last few years where we start to have job titles now saying distributed systems engineers. And effectively what it is it's instead of 10 years ago, 15 years ago, where we were creating monolithic systems where we had a single deployment, we're now in the era of SOA, so service-oriented architectures, and microservices and different systems talking amongst each other. And we've gone urban sprawl on the types of systems that we built. So an example would be I worked for a company in the US about 8 years ago, and we turned a 1.6 million line code that was monolithic into 43 microservices that was written in 8 different languages, and we had no idea how everything was talking amongst each other. So distributed systems are becoming very difficult in order to monitor and understand how to scale. Now this image is from a tool called AppDynamics, which is a monitoring tool that if you configure your hosts correctly, then AppDynamics will tell all the different pieces about how system A talks to system B, talks to system C, and it will give you the latencies between everything. And as you can see, our distributed systems are becoming more and more difficult to talk to because we have one system that can talk to 20 different services internally, and then it's all about the collection of data. So it's very difficult, and especially more difficult if you work in a company that allows different languages. So, you know, you may work in a company that's very specific in the language that they use, but you also may work in a company that team by team can change the languages, and that becomes even more difficult to scale and monitor. One thing I've understood throughout the years is I used to believe that this was a joke. I really was always told that you must test on your local machine, and before anything goes through to production, you must be very confident. I'm now starting to become the opinion of that is impossible. Absolutely impossible in every way, shape, and form, because 1, I don't have all the pieces of the puzzle on my local machine. 2, I don't have anywhere near the same data source on my local machine as I have in production. And number 3, I don't have real users understanding what's going on and causing difficulties in my system. Now, I have a tweet, and I didn't include it in my slides, so if you just give me 1 second, then I can read it out. Okay, and this was actually one that's been very interesting over the past few days. You hear things like a QA walks into a bar, orders 1 beer, 99 beers, -1 beer, a beer with a random name, and so on. And then the last line of the new tweet reads, a real user walks into a bar and asks where the toilet is, the bar burns down. Because we always test the good parts through our system. We don't test the unknowns. And the only people that actually help us test the unknowns are our users. Users are the most chaotic people for our system, and we don't even realize it. How do you build a complex distributed system and be able to scale it? This is the biggest conundrum that we have in development now, okay? We're not doing new things. We like to believe we're doing new things. We're not. We're standing on the shoulders of giants, of people who have been there for many years before us, building systems and showing us how to build systems. All we're doing now is building bigger systems in different ways, more complicated, more in different languages, talking to each other, higher distributions of transactions, because the world has become much more digital. Therefore, our systems need to be able to scale more than what they used to be able to scale. Netflix said it best for me. They said the best way to avoid failure is to fail constantly. Now, of course, that doesn't mean that Netflix are having bugs in their system every day. That's not what the actual quote means. What it means is that if you are confident that your system will withstand failure, then it doesn't matter if you fail. Okay. Now, what that actually means in essence is you have to test for failure. You have to get people who don't understand your system and just let them loose on your system, because users are the best way of chaos, and they will find different pieces. So now we introduce something called chaos engineering. Anyone heard of it? It's become extremely popular in the past year or so. Okay, and it's been around for quite a while, and you just don't realize it. So chaos engineering is the discipline of experimenting on your distributed system, okay, in order to understand that your system will withstand failure. You can go and have a look at the principlesofchaos.org, and you can go and read more about it. I'm not going to talk about the theory of it because that's the boring part. Okay, well, excuse me, that's not the boring part. That's the part that you can read online. You're not here to listen to the theory of it, okay? So here, let's have a look at it. Does anybody believe their system does not have weaknesses? Can anybody put their hand up and tell me that they have no bugs in production? Exactly, right? Now, you usually get, at different conferences, you usually get one person who thinks, nah, yeah, I'm going to make a joke of it. And they put their hand up and go, I have no bugs in production. So one of two things happens, right, at that point. I'll either A, offer them a job because they're the best coder that they lived, because if they really believe that they're delivering code in the production without any bugs, then they're awesome. Or number two, it's because they don't actually have any metrics, monitoring, and logging to understand that there are bugs in production. 99.999999999% is that case, and it's not because they're the best coder ever lived. Now let's have a look at what I mean by this. Okay, so let's take a typical system. Okay, now a system has layers. Okay, now depending on where you are and what you do, we'll talk about this. Okay, so you have hardware, you have a network layer, you have a database layer, a cache layer, and an application layer. Okay, now if you're in the cloud, you may not see the hardware layer or the network layer. You'll have a database, cache, and application layer. If you're in serverless, you probably only see the top one. But by the way, whether you're in the cloud or serverless, they all exist. You just don't have exposure to them. Okay? They're hidden away. They're managed by someone else. Now, because we have different layers, we can inject chaos into any one of these layers in order to understand how our system performs. Now, what I mean is, let's start at the bottom. You have your own data center in your office, or your own rack for testing. Go and pull the plug out. What happens? You'll probably be fired, but that's a different story completely. But you'll actually see what goes on inside your company, because if you pull the plug and you cause chaos in your entire system, you have a problem. You probably may not have tested your disaster recovery before, but it's maybe a good test in order to understand if you have. Network is a little easier and a little less disruptive to test. Just pull a network cable out. Remove access to your environment. Watch what happens. Don't take your environment down, just remove the access. You'll probably, again, get in some trouble, but less trouble. And as we go forward, the chaos that you can introduce gets less and less and less. Okay, database. Somebody said before, if I just removed one of my database disks and test the application or the database replication, would that be a problem? I was like, yeah, that's not really that's a very extreme form of chaos engineering at that point, because you're then testing the reliability of the database you've chosen rather than your own system and your own architecture. But more than likely, most people test at the application and cache layers, okay, because those are the less critical parts that we actually need, because we don't need to really test our database, because if we bought an off-the-shelf database or we use an off-the-shelf database, they do their own chaos engineering or their own resilience testing to make you understand that it's as expected, okay? And that's very important. But application layer, you can actually introduce a very simple experiment that I'll show you in a second. So the principles of chaos engineering. 1, you must define a steady state. And I'll give you a real-life example of this in a second, okay? These are very wordy, but these are the official principles. Number 2, You must hypothesize that the steady state is normal and will continue as normal every time. Number 3, you're going to introduce events that mimic real-world events, see how your system works. And number 4, you're going to try and disprove your hypothesis of steady state continuing. So how that does, and it boils down in a nutshell, is as follows. Okay. Number 1, define our steady state. When my application server is up, it can connect to my database server. That's our steady state. That's the application talks to the database. Okay. Number 2, hypothesize that the steady state will continue. I can say when the database goes offline, I believe that the application should continue to function normally. Okay, so we don't throw 503s for the user. What we actually do is we degrade gracefully inside our code base, and we give nice user-centric error messages so that they understand that there's problems in the site, but that they can use other functionality within the system. Number 3, what I'm going to do in order to actually introduce a real-world event here is I'm just going to make a simple IP table change or a security group rule change that blocks the port of the database server that your application can talk to. Because by making that very simple change, you can reverse that very fast if there are problems. Okay. Number 4, when I do that, I have to then prove that when I run this experiment, that the system will continue as normal. Okay. If it doesn't continue as normal, swap the security group rule back, make sure everything goes back to normal, and then you can make changes within your application in order to degrade gracefully. Okay, so chaos engineering actually allows you to iteratively improve the architecture of your system, but by introducing small events at the same time. Now, you can't do this without monitoring. It's impossible, because if you don't know that the user is being served a 503, or that your system is under strain or it's causing problems or request queues, you have no idea if it's been a successful test or not. And it's really important to understand your monitoring. We are much further along these days than just pointing a Nagios server at our cluster and us telling it if it's got host is up or down, or if the disk is full, or if the CPU is running too hot. We're much further along. If you're in that space right now within your company, try and make 2019 the year in which you move beyond that level of monitoring, because we can do a lot better in this space. So I'll give you an example. And this is number 1 and 2, system availability and service metrics. If you get a page, or your ops people get paged in the middle of the night that says the disk on our database server has filled up, they'll just look at it and go, great. What more information do I get from that? Is it because it has filled up over the last 4 hours? Or has it been continually filling up for the last 6 weeks and no one has even noticed that that's the case? You want extra information in there, like the rate of change across the percentage of time, to understand that is there something going on in our database server that's causing extra events to be logged to our disk? That's context that will help you identify that there's a problem. And it's very important that you take that context. Then we can get into better areas of metrics, okay? Does anyone work in e-commerce here? Okay, so on a normal day in your e-commerce website, can you tell the amount of people who have logged into your system or registered or who have made purchases? So that is user-centric metrics. And if you don't know your seasonality and your changes of time about the number of people who use your system, then it's very difficult to identify when there are problems for users. So Amazon or any real main e-commerce website that has this feature can tell at any point in time, in any second of the day, if there's a real issue in their system, because they will understand the standard deviations of change of their user-centric metrics. Okay, and they can quickly identify that if it drops below a certain percentage, there's obviously something wrong, and we can investigate that immediately. Really crazy important to collect those metrics. And number 4, which is probably even more pushing towards different things, service-specific metrics. So anyone collect latencies between database calls or between systems within their environment? You should be able to understand if service A talking to service B takes a fraction of a time longer or a standard deviation more because you can actually help identify network failures within your system, or disk failures, or I/O, or request queues, or all of these different things. Okay, you must have a combination of all of these style of metrics to be able to drive chaos experimentation. If you don't, you may as well just go and pull that plug out of your database server or out of your data center, because you're completely blind as to what's going on in your environment. If you want to know more about metrics, there's a wonderful book. Okay, I would love to say that I get paid by telling people about this book, but I don't. I just believe it's the best book out there for monitoring right now, and it's by a guy called James Turnbull. He has written so many books, it's unbelievable, around different pieces of infrastructure and operations. But go and read it. It's wonderful, and it will give you an insight into different things going on. So we've talked about what chaos engineering is, and we've talked about the fact that we need a prerequisite of monitoring. Where did it come from? So I don't think there's a country in the world now that hasn't heard of Netflix in any shape or form. Okay, it's one of those things that has been growing and growing and growing and growing and growing over the past few years. And what has made them extremely good is the fact that they practice exactly what I'm talking about on a day-to-day basis. Okay, in 2014, they wrote a blog post called "Introducing Chaos Engineering." Okay, now it didn't. This doesn't mean it was created in 2014 by Netflix. They actually started doing this in 2008, and they originally understood it internally as resilience engineering. Okay, but the word resilience engineering, or the term of resilience engineering, is not as sexy or as easy to promote as chaos engineering, because when you come up with a new word for something, we're really good at being able to market it within IT. So resilience engineering is something that's been around for so many years, it's unbelievable. Some banks have been doing resilience engineering for a long, long time, okay, because they need to understand what happens when systems go wrong, otherwise people will lose their money. Okay, Google have been using resilience engineering since the dawn of time, basically, since the first time, because if something goes out in the world on Google, then we have problems. Okay, there is a big, big issue on the internet if Google goes out. Okay, but what Netflix did is they introduced a brand of tools around this. Does anyone know the Simian Army tools? Okay, now they've degraded some of these. They're no longer available. They're no longer working anymore. But they have introduced these in a number of years in order to help different areas. Okay, so the first one that was created was, I'll explain first. Netflix used Amazon, AWS. Okay, and for those who don't use AWS, there is a very simple structure of it. Okay, you have regions, so these are geographic locations around the world, which they can be used to serve content directly to the user close to them. Within a region, you have a number of availability zones, so these are tangibly related to data centers, and they're geographically split so that if you lose one availability zone, then you have other availability zones within the system, and then you launch instances or databases or application servers within an availability zone. Okay, so there are 3 levels, okay? And they introduced a number of tools that did a number of things. So Chaos Monkey was the original tool that they introduced. And Chaos Monkey was a very simple tool that used to do things like destroy the application server or the instance, okay? Force that the application server CPU went through the roof. You know, force that it blocked network access and so on and so forth. Just very simple things that you can go and have a look at some chaos experiments. Now, when they did that, they understood that yes, their system could actually be resilient to problems with losing an individual instance. So they were like, okay, how can we get this to the next level? So then they introduced something called Chaos Gorilla. Okay, I don't know the exact orders of magnitude, but of course a gorilla is bigger than a monkey. Okay, and what they did at that point is they said, let's simulate that we can lose an entire availability zone, but that our system can still continue to work. Anyone use like event-driven databases like React? So these different tools, okay? These tools work on a quorum system where you need a percentage of your servers to be online, otherwise your system is not available to be used, okay? So like one of the big ones I like to give an experiment of here is Elasticsearch, Okay, so if you have a 3-node cluster of Elasticsearch, your quorum would probably be 2, which means that you can survive failure of one Elasticsearch node before the system goes down. So you can still perform well when you have 2 out of 3, which means if you lose an availability zone, then your system will continue to perform as necessary. So then they proved that that was the case and their systems were resilient to this. And then they decided, what happens if there's like a nuclear apocalypse or something like this and we lose an entire region? Like the whole of West EU has been like ripped off, and or Brexit occurs, and we no longer have data centers in the UK or whatever. So they introduced this thing called Chaos Kong, and Kong is much bigger than Gorilla, which can actually simulate what happens when they lose an entire region. Now this was extremely interesting because in 2015, I can never get the date right here, there was a huge failure in US East 1 in Amazon. Okay, US East 1 is one of the regions in Amazon, but it's actually their first region. It houses all of the S3 infrastructure, and it houses all of the Route 53 infrastructure. Okay, so when that goes down, you see cascading effects across the internet. You probably lose systems like HipChat. Anything that's like more software as a service starts to actually degrade based on the fact that Amazon have lost US East 1. Because so many things use S3, so many things use Route 53, and so on and so forth. Netflix had been practicing for many, many, many months before they had an outage that they could fail over from different data center to different data center, or excuse me, from different region to different region to different region. Now they were actually able to fail over completely from US East 1 to US West 2, and their entire system only took 7 minutes of downtime. Now that's massive, considering that some people were down for like 24 hours. And that was a huge, huge, huge thing. And this is really where the spawn of why chaos engineering has become so important, because you want to be able to withstand outages. If you're going to put yourself at the mercy of a third-party company, you need to understand that if something happens with them, that you will survive and everything will work. Because they have problems just like we do. Amazon and AWS are not built by robots that are perfect. They have bugs in their system like we introduce bugs into our system. And this is really important. Now, just to show you that I am not like making this up. And I said at the top of the hour, I said, we effectively are building a new cloud right now. I work for Samsung, as I said. And we are following these monitoring rules. Okay, this is my dev system, so there's nothing secure and sensitive here. But you can see that we're actually collecting so many logs on a day-to-day basis. Okay, in fact, if I take away this application search, it actually works out to be 49 million logs. And this, we actually drop our entire log database every day. We're using a company called Humio, and we can see what's going on. And we can see at any point in time what logs are going through. And I can actually like live stream our logs for the past minute in our dev system. And you can see that we've got lots of different things going on in here, like security handshake failures, if there's an SSL failure, and so on. So that's one level. We log everything. If I resume the stream, then you can see what's going on. So we absolutely log everything. Number two, we love the open tracing initiative. If anybody uses things like Zipkin or Jaeger or any of these tools, we push every single metric that we can through these tools so that we can understand exactly what's going on at any point in time, and you can start to see the standard deviations within our system. Now, if I can zoom in here, you can see that that number right there is 30 milliseconds. And we can see that the most of the calls within our system are in the 0 to 10 milliseconds range. We have a huge chunk of calls that are in the 10 to 20 millisecond range. And then we have some outliers that are slightly more. And we can go and we can have a look at any of these systems. In fact, if I go and change the operation type to be a VM. Come on. You can see every operation that we do is listed in here, 100 different operations. So if I go to VM create, I'm hoping there's some data in here for the last 6 hours. there are none. Let's go and try a VPC. None. Damn it. Data center. None. Okay, so we're just going to go back to the all because it's easier. So this is another. So this is because this is a development system as well. This is very specifically towards the development system. We don't need this data, right? We literally drop this data. It's a Cassandra database. We drop the key space every morning so that we don't have hundreds of gigabytes of logs of data, but we can start to see on a given day what all the different pieces are. The next thing we do is we graph everything, and I really mean we graph everything. So this is we're very CQRS based, so we separate our reads and our writes. And this is all of the distribution, and it really doesn't look very good in that screen. But you can see that there are lots of numbers and lots of little lines and graphs here, and it's all histogram values based on different things. So we can see that the highest on this left-hand side, this top value right here, is actually 0.07 seconds. So we can start to understand the standard deviations of our calls throughout the day at different things. And it's really important that each of our systems all work in that manner. So when we create a new microservice, a new application, it follows the same pattern. It gets all of these different things and all of these checklists, operational checklists, to make it ready before it goes through our system and goes out there. And metrics is like metrics, logs, and tracing are the big three that we need. If it's not there, the system basically doesn't exist online. So we practice what we preach. We try to practice what we preach, of course. We try. In essence, it's not always the case. So who else practices this? Uber, Dropbox, Google, Amazon. You name any major company that have had an outage in the last 6 to 12 months, and they will start to be exploring chaos engineering within their system, or sustainability engineering, or resilience engineering, whatever title you want. Because unless you practice this and you're a huge company that you have customers, your customers will cause you hell right now. And it's really, we're in the dawn of trial by social media. We really are, because if anything happens on any site that's a third-party site, the first thing people do is they will go to Twitter and they'll write a horrible tweet at that company, and it'll be retweeted thousands of times and everyone will see it. And your PR will go, it will plummet. So unless you're practicing this and unless you're actually learning what happens going through your system, you can really take a big monetary hit or a big profit hit or a turnover hit. Because if you have a third party out, if you have an outage as a third party and your customers are affected, you're in some trouble at this point. Now, like Uber started doing this because they had a failure of their log replication from their master database to S3. And what actually happened is their database filled up and filled up and filled up and filled up and filled up. They ran out of space. Nothing could write the database. Database fell over. Now, if Uber's database falls over, you know what happens. People can't really make requests, or you can't make charges, or so on and so forth. Okay. Dropbox, again, master slave replication between the system in their database this time, not their logs, caused Dropbox to fall over. Google and Amazon have been running this for so many years, it's unbelievable. So, but they actually call it disaster recovery testing, and they don't adhere to the name chaos engineering because they've been doing it so long. It's part of their fabric of what they do. It is part of their culture. It's part of what they do on a day-to-day basis. So they believe they don't need to make it sexy. And then companies like Microsoft, for example. Microsoft had a huge outage maybe 3 months ago where Azure dropped in the US South Central for like, I think it was down for maybe 2 days because of a thunderstorm that hit one of their power generators in their data center. So they will now be starting to investigate this in order to understand how to fail people over and how to fail their systems and their platform as a software as a service and platform as a service offerings to move across the different data centers at that point. System failure happens whether we like it or not. Okay? We never realized that it happened because we kind of kept ourselves in blinkered into this little area that we were working on. But now we're in the era of understanding much more because of things like DevOps and things like chaos engineering, and how we're in this idea of you build it, you run it, because that is like a huge thing these days. You no longer like take this application, you create it and throw it over the wall to the ops team, and they manage it in production. Developers, QAs, BAs, ops, they all work much closer now in IT than they ever have before. So therefore, we're much more aware that there has been a problem that has happened. There are actually some tools that can help you. Of course, there are enterprise tools that can help you as well, like there are in any good part of IT. But Chaos Toolkit is one. Okay, Chaos Toolkit is an open source framework that you can go and you can extend, that will talk to different cloud providers and so on and so forth. In fact, if I exit out of this, the Chaos Toolkit is very interesting because it has different drivers for different things. So the drivers can be, Kubernetes, which is huge right now, Amazon, Azure Service Fabric, Cloud Foundry, Google Cloud. Major clouds are starting to write extensions and drivers that will allow you to integrate failure into your systems within those environments. Okay, it's all open source. It's written in Python, so it's very easy to extend because Python is one of those languages you can pick up and get going with quite. It's got a nice barrier to entry rather than, you know, if it was written in Clojure or if it was written in like Go or Java, it's much higher barrier to entry. So it's very easy to get going in that area, which is very good. And you have another tool called Gremlin. Gremlin is a much more enterprise-based tool, okay? And you can, what Gremlin have basically been doing over the past 6 months to a year, they've been hiring the best people in the field in chaos engineering, and they have been like starting to build this tool to like of all these years of experience to make this work for different people and understand different things. And you can go and you can speak to them and you can see what's going on. I have not seen a demo of Gremlin yet because I don't want to pay for it because I'm cheap. And I like open source things. I'm a big supporter of open source. I always have been. I always will be. And that's not to say it's a bad product. It's not. I've heard very good things about it, but personally speaking, I have not used it. So there are tools available to do it. And I don't really have time. I have like 10 minutes and I have a lot extra to get through. So usually as a 1 hour talk, I would show a small experiment here or like a chaos monkey or something. There's a tool called Katacoda, okay? And katacoda.com, you can go there. You can log in using your GitHub authentication. And if you search for Chaos Toolkit, in fact, we can go and do it now. I have it open. So if you go to Katacoda, and it has lots and lots of interactive tutorials that you can try for different things. And if you type Chaos Toolkit and run in your first chaos experiment, it says it takes 7 minutes. First thing you would do is you'd switch on like a Python environment. The next thing you check that chaos was installed, which it's not for some reason. Maybe they're having problems, but that's really funny. So you can go and you can mess around and try different things. This is all as a service, so you're not destroying your local machine, you're not destroying your local database, or you're not destroying your own environment within your company, which is a big +1 to get started and understanding different things. But you can go and play with this and you can see what's going on. So where do we get started? Now is the interesting thing. And I learn new places to get started every time I give a talk in this area. So I'll give you the most basic example, and then we'll go to something more side on it, okay? Hands up who has a development environment that everyone integrates to in a local day, every day, and sometimes they have to SSH into the boxes in your development environment. So a couple, okay? Somebody asked me, I gave this talk a couple of weeks ago at a conference in St. Petersburg, and they were like, where can I get started? And I said, so I asked them, do they have this scenario? They said, yes. And I said, is it monitored? They said, no. I said, cut port 22. Just turn off port 22 or block access to it and see how long it takes people to understand that they can't SSH into the box that they need access to. Okay, I got an email from him a couple of days later. He was like, really good. It took 3 days for people to realize that they couldn't SSH into the box. And what it's actually helped us to do is they put some monitoring in place to make sure that that box has port 22 open. What do I do in the next part? It's like, okay, so what you've done right now is you've exposed that you have some weaknesses around your monitoring and alerting. Okay? So the next time, why don't you just turn off your application web server, see how much people understood. They came back to me, and it only took him 1 day to come back the next time. Very nice guy. He's helped me a lot, like, understand how smaller companies get started. He says it took people 3 hours to notice that the web server was offline. Great. We went from 3 days to 2 or a few hours, okay? At that point, they put some monitoring in place around that. So he could understand, just by disrupting the developer's workflow on a day-to-day basis, that they were missing the basic monitoring that they needed for their environment. Now, you may laugh and you may think that this is really trivial. It's not. What doing these small pieces do is they expose weaknesses within your workflow. And if you can't get these pieces of workflow right, development and locally, there's no way you can run these types of experiments in production. It would be irresponsible of me to stand up here and tell you, start destroying your production instances, or start turning off access to your production web servers or database servers and so on, because it will cause serious problems for your company if you don't have the visibility to understand that there are problems. The next thing what I told him, and I'm really waiting to find out how this one goes, is every X amount of days, here's your goal. I said, by the end of this year, by the end of 2018, I said, have a goal that every 7 days within your environment, you're able to destroy, not all at the same time, of course, but one machine at a time within a web server cluster, and that your system can automate itself to replace. Okay, so basically mimic what Amazon autoscaling groups or Azure machine scale sets do, okay? So that if you have 3 machines in a cluster, the first thing you'll do is you'll destroy the first one, and your system will kick in and monitor and say a machine has gone down, and that you have the tools that the machine will replace itself. Okay, so if it's a manual, start a machine up, and then it checks in the chef, or if it has like cloud in it, or all these different things. But what you need to do is you need to measure how long it will take for an individual machine in that cluster to come back and replace itself. If the machine cannot replace itself, there is your next goal. And you really do start very small like this, and it's really important to start quite small like this. So you can take any of these, and then you can build on top of each one. Okay, and if you're sitting here in a privileged position right now where you know, yeah, my system's monitored, yeah, my application servers are destroyed, and they can bring themselves back up, the next one you can say is start cutting off, again on development, not in production yet, start cutting off access between your database servers and your or your cache layers and your application servers, and start to notice the response time changes coming through your system. Caching layers are one of the best places you can actually cause chaos. I worked at a company. Wow, this is always very funny when I think about it. I worked at a company where none of the developers could run any of the UI on their local machine because the product and marketing team used a tool called Optimizely in order to inject JavaScript into the UI to make the UI change look and feel for every single person who hit it, okay? And there was actually a known query string, and I'm not going to tell you a website because the query string still exists, where you can go and you can put on the end of the URL $optimizely equals false, and it will turn off the UI. It effectively turns your entire UI off. And we used to run experiments within the company, and we used to say, you know, you bring it up locally in your machine, and then you take a screenshot, and you send it in the chat and say, can someone tell me who's broken the website? And the marketing people used to be furious, and they'd run around and try and work out who was doing what and what was down and where was the monitor and stuff. And then we go, you just take the query string back off in the website, and you would send another one saying, oh, it's back, right? And this is the type of crap that we do now in this industry. We really are, we're doing our own, we're causing ourselves our own chaos. And of course, I'm not saying that marketing teams doing this are bad. That's not the case at all. But your system should at least degrade, because if that Optimizely service went down, then you would have no website. Your users would be completely cut off from trying to do what they needed to do. I almost gave it away what we did there, but I didn't. So you can really start to cause your own chaos within the system. And if you're really starting to get good in this area, I'm going to challenge you one more thing. Anyone ever heard the term A/B testing? A/B testing is a form of chaos engineering. Think about it. You take a very small percentage of your user base, and I do mean such small percentages, and you push them through an unknown, untested path, and you try and work out what happens when that small percentage of people go through that user base. So you may think it's trivial, but sometimes, in fact, there's no two people in this room that see the same version of Facebook. No two people. That's like a form of chaos engineering because they're trying to work out what is the best possible experience for the user because it's personalized for you. And it may look the same on the face, but it's actually not under the hood. Okay? Amazon sometimes do it because they do some random things like they change the position of buttons 1 pixel to the left or the right, and they work out the rate in which people can actually still use their website. Rounded corners are another one. Okay, remember when rounded corners became a thing, like, I don't know how many years ago, and the world became UI and JavaScript, authors started writing all sorts of frameworks for rounded corners. You can start to test how different rounded corners frameworks can affect the sales levels in your e-commerce store. This is all chaos engineering. Now you understand that the term is not new. We have been doing this for many years. It's now we're very good. It's the same as DevOps. DevOps was packaged up and DevOps was made a thing, and now you have consultancy companies around it. Sorry, consultancy companies, I'm not telling you you're bad, but you have consultancy companies around it making money based on the fact that there's a new sexy term in the industry, and now the same thing is happening in chaos engineering. There's a new sexy term that people want to get into, and I promise you, within the next 4 years, and if it's not correct, I will buy everybody in this room a beer, or a whiskey, or a wine, whatever you want to drink. But I promise you, within the next 4 years, you will have a lot of chaos engineering consultancies that will help you run chaos within your environment. You can start anywhere. You really can start something so small. Turn off Slack. There's a communication barrier. There's chaos within your environment. How can you communicate with people if you're a remote team? Do you have recovery scenarios in place that if Slack goes down, that you can then keep talking with people within your environment? People laugh, but it's true. That's a chaos experiment. Chaos is not just about destroying your production web servers. Please remember that. It's about introducing system events to your environment which stop you doing your job and stop your customers getting the best results that they can. There's a lot of resources here, okay? You can go and have a look at these. The first one's Principles of Chaos, as I said. There is a Slack organization that you can go to and you can listen into and ask questions. And that is always the best place to start when you're getting started. Okay? The same as in Agile, the same as in DevOps. It's about understanding, it's about sharing, and about understanding how people have got started that may give you ideas on how to start in your environment. Okay? There's a GitHub link that's got like so much curated information. You can go and it's like blog posts and articles and all these different things. You can, of course, remember there's no such thing as a single tool that you can take and just slot directly into your environment. You can go and have a look at the source code of the Simian army. Start to think about how you can write tools within your system because you will have to extend these tools. They won't just work out of the box. And lastly, there was, of course, like every good sexy term, there was a conference. Because this is what happens, you know, a new terminology comes up, you have a new conference around it. So Chaos Conf was a thing. It happened at the end of September, just passed, and it was, I have to say, there was some fantastic content there. There was, I think each video was like 25 or 30 minutes. It was short talks, and you can go to YouTube. The entire video list was actually created, and you can go to youtube.com, search for Chaos Conf, and you can watch all the videos and learn lots of different things. If anybody's got any questions, come and find me at the front, or I'll be outside having a coffee. I've been Paul Stack. Thank you so much for being here, and I hope the last talk of the day goes well for you.